Thanks for giving me this opportunity. So I will try to explain the ongoing project that we're doing on energy storage as a service. So this project boils down to developing the technical interfaces and the commercial interfaces, as well as some regulatory interfaces relating to 3 types of services provided by the same energy storage. So the first one is to provide power quality in terms of availability of power, and the end user requirement in this respect is 5 nines. So that's significantly higher than the type of availability that you normally achieve within a power grid, irrespectively if it's a local grid or a medium voltage regional grid. So the power quality is the first service. It's provided to a protected load. The second service that this energy storage provides is peak capacity. So the technical solution that we have developed is providing 7.3 times gearing. So essentially providing 730% of the capacity that the energy storage is using in the local grid. So it's a multiplier in terms of the type of capacity that can be used at the peak compared to the load that this is requiring, and the type of capacity it's requiring from the local grid. So it's a quite significant gearing. Finally, we are providing frequency regulation. The energy storage is capable of providing services with a 3-second response time to frequency deviations, and those are the 3 services that the energy storage provides. The energy storage as a service concept is distributed in the sense that it's a model that we have developed to permit a scalable and also localized energy storage solution that can be put into the local grid rather than in centralized locations in the national or regional grid. So the empirical approach we're taking in this particular pilot is based on 2. We wanted to address 2 research questions. First, what is the technical and financial performance of a multi-purpose system compared to conventional single-purpose system? And in this case, we're benchmarking the multifunction system to a single-purpose UPS system, where the protected load is protected by 2 parallel UPSs that provide power to the protected load. Secondly, and this is equally important to us, what would be the commercial, legal, and technical interfaces that are appropriate to deliver this kind of services to the market. And I should say that we're seeing a tremendous opportunity in providing services of this kind with respect to the kind of market development we're seeing. Just to give you an idea, we have investigated and looked into the plans of the largest multinational ICT companies that are currently sourcing land for this kind of systems in the Nordic. So they jointly sourced roughly 12 million square meters of land for cloud computing in the Nordics, and that translates into ambitions to provide roughly 4 gigawatt, 4,000 megawatts of capacity of UPS capacity to cloud load in the long term. And from the perspective of the power system as a whole, that's a significant potential capacity that can be used also for other purposes. So the pilot that we are running is one that involves an energy system that is, as I said, one experiment and 1 control. So there are two autonomous systems. The joint capacity is 600 kilowatts, and the battery storage, which is housed in these 8 racks, is 200 kilowatt hours. It's a system that is relatively fast in terms of charging and discharging. So it's a relatively fast system. It has multi-layer protection of these lithium-ion batteries that are in the racks. We are connecting at the local grid level at 400 volts. It's a 1250 amps connection. We have a single feed to the non-critical load, and we have dual feeds to the critical loads. And we are optimizing the system with a single PLC. That's the system. So this is what we did in the first quarter of 2019, we completed the design of the system in detail in January, February, and we have done the connection to the local grid ongoing from January to May, and it's still not really completed. We have ensure that we have market access to the FCR market. It's not completed, but essentially done. We have done the installations, and we did commissioning of the UPS system about 2 weeks ago. So essentially the energy storage and the UPS is now commissioned. So here is the sharing part of this talk, since we are here to share our experience so far. So the first important lesson is that it's non-trivial in multiple dimensions to optimize the battery system to the tasks at hand. It sounds trivial, but it's not. It's in practice a non-trivial issue to optimize the battery system. Secondly, it's moving from the theory to an empirical implementation is not trivial for another reason, which is due to the fact that the major manufacturers of these kind of batteries are not easy to deal with, particularly since the counter question you get as a company at this stage of market development is that they want to know that you can ensure that the volume that the order represents is sufficiently large, and I can give you a number if you want to know it at some point, but it's a very large number. And thirdly, it's interesting, but it's currently, due to the immaturity of the market, the process of connecting this kind of system to the local grid is very opaque. And I would say, to be a little bit honest, that it's probably because there are some uncertainties with respect to how the local grid would operate with this kind of system. So it's very opaque and very difficult to deal with as a commercial player. The fourth is that we have found that it's very critical to find a way to coordinate. Thank you. The local grid with a UPS manufacturer, and again, that's something that we can discuss in detail at some point. We have also experienced that some of the BRPs, some of the balansansvariga in the Swedish market, are very reluctant to accept new competitors in the FCR market. And there are some uncertainty remaining regarding how the energy storages will be treated in the FCR market. Okay. Let me just say that we are connected to Ellevio's grid LGG, and the major issues that are still remaining are that there is an exaggerated worry among the local grid operators regarding loss of mains. And I can tell you the technical details why this is a non-issue in practice, but it's a huge issue when it comes to connecting to the local grid, and the local grid operators has a long way to go. Secondly, they pay you very modest, if any, compensation for your services to the local grid. So we did a little bit of a survey, and this is something we can discuss a little bit in more detail, but we did a DSO survey, so local grid operator survey, and this gives you an idea of where we are. We came to this with the idea that the future looks bright, and we're going to do great things, and we're going to do it very fast. This is not where the local grid operators are. So we surveyed 10 of them, and they are, as you see here, spread in the major markets in Sweden. And there is no experience, there is no plan, and if anything, they're willing to pay a little bit for loss reduction, but that's it. They have some technical requirements. Some of them are in need of revision. All right. So I'm just going to say that there is a significant potential for a resource that is in between synthetic inertia and the current products, FCRN and FCRD. So that's something we're working on, and that's not available as a product in the market at the moment. So the way forward then, and I'm going to finish with this. We are currently developing some commercial and technical models for providing local services that are beyond the arbitrary real estate border. So currently the model is built on the assumption that end users are either consumers or they go off-grid. So we're trying to develop models that are allowing for a little bit more innovation in that respect. Secondly, we are developing an algorithm to optimize the charging and discharging for these three purposes. Thirdly, we are looking into the profitability of these services. And fourthly, which will be also the fourth aspect will be important in the long run, we do intend to, based on the pilot we're currently running, we intend to develop the design further to make this even more competitive in the long run. So I guess that wraps up what we're doing in terms of energy as a service. Thank you.